Hello students, welcome to Office Hours with me, your naughty professor. Today we're going to do a little bit of geometry, which is a personal passion of mine. I thought we'd just start by playing with some triangles and see how far we can go. So, let's take a right triangle. It doesn't get much more basic than this. Everything can be broken up into right triangles in pretty nice ways, and so if we can really understand this baby, we're in business. Now, an important thing to know is that whether we're dealing with radians or degrees, we just sort of have to pick a measurement that describes what we're talking about. When I say this is a 90-degree angle, I really just mean it's a quarter of the way around the circle. All right, if I go all the way around, that's 360, and that's just by convention. That's just some old white guy decided that's the way it should be. And so if I take a quarter of that, that's 90. If we take 4 angles like this, it forms a full rotation. And so we just divide 360 in 4. 360, incidentally, is kind of a nice number because it is divisible by so many things. It's nice to have a number that you can divide by 10 and 3 and 5 and 2 and 4 and 6 and 12 and so many different things. I generally like numbers like that. I mean, primes are really cool, but a number that can be divided by a bunch of shit is pretty exciting. And in particular for angles, it's pretty nice. We can take a sixth of the circle, we can take a 12th of the circle, and we can get a lot of different fractions out of this. I'm not sure if that's why they picked 360, but it works for me. 2 pi, on the other hand, the reason there are 2 pi radians is because to define radians, we look at the unit circle, a circle with a radius exactly 1. And a radian is exactly the amount of rotation that I need to get a curve of length 1. So what I mean by that is not that the distance between here and here is 1. What I mean by that is if we take that curve and we stretch it out, it's going to have a length of 1. So we take a curve and we stretch it out, and then the length is 1. This string has length 1. All right? So then if we take a string and wrap it all the way around the circle, it turns out it's going to have a distance of 2 pi. And by that I mean we define it to have a distance of 2 pi. There's also a number tau that we don't see as often. Some people think we should have defined tau first and just gotten pi from there. Some people think it's easier to define pi and then double it to get tau. Either way, it's just a made-up number. We use Greek letters to make it look all fancy-schmancy, to make it seem important, I guess. But they're really just numbers. They're really just things that we defined to be what they are. Pi turns out to be 3.14159 yada yada yada. Memorizing digits of pi does not make you a mathematician. That's really all I've got. I know some people who have memorized a bunch of them, but memory has never really been my strong suit. So, that's pi. The yada 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 is the important part, though. The part that I don't say is the important part. The part where the number just keeps going and going and going and going, and just when you think it's gonna stop, it goes some more. That's what's cool about pi. Pi is called a transcendental number. It means that it can't be expressed as a solution to an algebraic equation. It's something funky all its own. And there are actually more numbers like that than there are numbers that can be expressed as a root to an algebraic equation. But I digress. We were talking about a very simple triangle. I always go too far when I'm trying to keep things simple. So, back to this baby. All right, we've got a 90-degree angle. We've got 2 more angles. In order to see what those angles are, I'm just going to take another right triangle. In fact, the same right triangle. So I'll draw a copy of this right triangle. Okay, it's a right triangle. So there's that. And now here's the cool thing. If we're playing with pieces of paper, and this is a great way to learn, just get a scissors and paper and pen, compass and protractor if you're feeling really excited, and play around. If I take these triangles and I maneuver them around, we end up with two copies of the same triangle that are actually going to fit like this. And the reason for that is simple, that I've got the same distances here and here. And we know that since it's a right triangle, it's going to fit together into a nice rectangle. And these are going to be right angles as well. Just the fact that we can do this, that we can make the same kind of shape out of two more copies of the same triangle, that gives us a hint, that gives us a little bit of an idea about what these other angles are going to be. And it turns out that these two angles are always going to add up to 90 degrees. The other angles of a right triangle add up to 90 degrees. I recommend anyone who's trying to learn geometry to play a little bit. Just make some cuts, make some shapes, and fit them around each other in different ways, and see what you get. It can't hurt, and it's probably going to give you a pretty good idea of what's going on. I can take two different triangles that aren't right triangles, and I can fit them together in a very similar way. Oh dear, I'm going to have to go really low on the board to draw these triangles. I can do that, and then copy that to make what's called a parallelogram, and we'll still end up seeing that the two angles fit together in the same way. And in fact, if I take all of these angles and add them together, if I were to make, say, a copy of the parallelogram over here, I'm going to end up with 180 degrees between all of these angles. This kind of play is what I like to do for maybe a couple more videos, just to have some fun with it. Hopefully I'll upload these in order so you can see. And I think I can call it there. Just sort of introduced the ideas of playing with shapes and where some things come from. And that was a lot of fun. We did some good work. What do you think? Alright, so I will see you next time. Bye, lovely students.